Hi, welcome to Tammy the Tutor. Today we are going to do section 1.1.3 from the CC1, the 6th grade textbook. If you go to your homework problems, the first one is number 19. And these are dot patterns. This is the very beginning of learning how to deal with these patterns. And pay attention, I'm going to show you a really good way to look at them because you're going to continue to do this all throughout middle school and even some in high school. So it says study the dot patterns. Assume each pattern continues to increase by the same number of dots and in the same locations for each figure. For each pattern, sketch the 4th and 5th figures, then predict how many dots will be in the 100th figure. Okay, so if you look at figure 1, you can count. There's 1, 2, 3, 4 dots. In figure 2, if you count them, there's 1, 2, 3, 4, 5, 6, 7. And then figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. You can look at this a couple of different ways. Something that I learned to do early when I was dealing with these kind of patterns is I made myself a table, and I'll just show you, like I would say in figure 1, I'm going to make a table, so I'm going to draw it like this. There are 4 dots. In figure 2, there were 7 dots. In figure 3, there were 10 dots. Okay, I'm just going to leave that there for a second. And because it actually told us to sketch the 4th and 5th figures, I'm going to come over to this side and draw them out. So I'm going to say, okay, this is figure 4. So remember, figure 1 had 4, figure 2 had 7, figure 3 had 10. So you can probably see the pattern already. Can you see how many they're adding each time? Yes, they're adding 3 dots each time. So I know automatically figure 4 should have 13 dots, okay? You do need to sketch them correctly. They kind of have to be in the right spots. So if you look at figure 1, that's your base. So it all increases from there. Watch what happens from figure 1 to figure 2. Vertically in figure 1, there are 3, but vertically in figure 2, there are 5, and then vertically in figure 3, there are 7. So that means just vertically, they're adding 2 each time. So I'm just going to draw what figure 3 had, and they had the 1, 2, 3, 4, 5, 6, 7. So, okay. 1, 2, 3, 4, 5, 6, 7. I know I need to add 1 on top and 1 on bottom. Make these look a little more conforming. Okay. And then look what happened when you went horizontally. There were 2 here, 3, 4. So find your middle dot. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right here. There needs to be 5. So there's already 1, 2, 3, 4, 5. So altogether there should be 13. So go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so perfect. Not only do I have the correct number of dots, but I have them in the correct place to follow the pattern that they've set. So figure 5, I keep forgetting what they have. So 3, 5, 7, 9. This one should have 11 vertically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5. So this one should have 6. 1, 2, 3, 4, 5, 6. So that's what they should look like when you've drawn them out. And that part is done, but you still have to figure out how many dots does figure 100 have? Now, here's the deal. They're trying to teach you a way to do this so that you don't have to fill an entire notebook up and do figure 6 and do all the dots and count them, and then figure 7 and all the dots and count them. They don't even expect you to make a table, which would be a lot faster than drawing the dots, but even doing that could take you a long time to get all the way up to 100. So you have to learn to find patterns mathematically. So that is why I also love setting it up in a table like this on the left, because I know that my top number always has to be multiplied times something, hopefully to get that bottom number. I'll just go ahead and take the mystery out of it for you. You're always going to multiply that top number times that that number that you use to add every single time. Remember, they added 3 every time to get to the next pattern. So in your head, go, okay, 1 times 3, well, that only equals 3. It doesn't equal 4. Okay, that's okay. What else do you have to do to get to the 4? You add 1. So look at what we have just figured out. If I multiply 1 times that 3 and add 1, I get 4. So it looks like we kind of have a little mathematical problem, an equation, if you will, to get us to the number on the bottom. See if it works for the rest of them, and if it does, then you know you're good and you could plug 100 in. So watch this. We're going to do 2 times that 3 plus 1. Well, 2 times 3 is 6 plus 1 equals 7. Look at there. That totally worked. We'll do it for 3. 3 times 3 plus 1. 3 times 3 is 9 plus 1 equals 10. Look at there. So we have figured out our pattern. So do you see how the number right here is always the figure number? Well, they said how many dots will be in the 100th figure. Okay, just go 100 times 3 plus 1. 100 times 3 is 300, plus 1 would be 301. So in the 100th figure, there will be 301 dots. Okay, I know this is a new skill and it's different, but don't be afraid of it because they're going to give you opportunities to do this a lot. And actually, I think it's pretty fun. It's like solving a puzzle. If you pattern it after the way that I've shown you here, you'll get used to it quickly and you'll get really good at just using your table to figure out. Don't forget, you always multiply this top number times however many they added. And then after you do that, just how much more do you need to add to get to that bottom number? And it really works every time. Okay, let's look at, let me clear this out because this is getting messy. And then let's work on B. So if you want to pause and try to set up your table like I did, go ahead and do that now. If not, so here's what we're going to do. In figure 1, there are 2 dots. Figure 2 has 4 dots. Figure 3 has 6 dots. I bet you guys can see the pattern already. So we have to figure out how many dots are in the 4th and the 5th figure. Well, look at this pattern. 2, 4, 6, 8, 10. Okay? So what are they adding every single time? They're adding 2 more dots every time. And guess what? When you multiply that top number times that 2, you go straight to that bottom number. You don't have to add anything this time. So let's come over here. We still have to sketch the 4th and 5th figures. They really wanted us to do that. So figure 4, figure 5. So if this one's got 2, oh, and the way they did this pattern is super easy. So figure 4 will have 4 sets, right? And then figure 5 will have 5 sets of 2. Okay, so, oh, we still have to predict how many dots would be in the 100th figure. So let's go over here. So what is the pattern? You multiply this top number times the 2 and you'll get the bottom number because 2 times 2 is 4, 3 times 2 is 6, and so on. So 100 times 2 is going to be, yep, 200. So there'll be 200 dots in the 100th figure. Okay, great. Let's go to the next problem. Okay. Says the value of a decimal becomes clearer when the place value is spoken or written as the number it names. For example, 0.1 makes more sense if it is read as 1/10 rather than 0.1. Write the following numbers in words so that the place value can be identified. Okay, so the first thing that I see is 0.4. Do you really think they want us to write 0.4 in words? No. They want us to use the right place value. Do you see that 4 is sitting in the tenths place? So the way that you would say it is 4/10. So a little bit more time consuming, but it's still good practice for you. You can write it out, 4/10. The next one, I know your instinct is to say 1.3, but what is that really in place value terms? So you say the whole number, and where you find the decimal, that's where you pause and you say and. So you would say 1 and 3/10. 1 and 3/10. It's like saying you've got $1.30. Okay, the next one is decimal 5/6, but that's not how you really say it. Do you see the last number, the 6? You have to ask yourself what place value is the last number sitting in. That 6 is sitting in the hundredths place. So therefore, the number is 56 hundredths. And you can abbreviate if you want to. Okay, the last one. Okay, 2.008. Okay, so don't forget there's a whole number, so I'm going to say 2 and where that decimal is. But look at that 8. What place value is the 8 sitting in? So you got the tenths, the hundredths, and then the thousandths. So it's 8 thousandths, right? So 2 and 8 thousandths. Okay, there you go. I'm gonna have to clear this. Well, actually I can come over here. So B, now reverse your thinking. Write the decimals that go with the following words. So this might be easier for you because you're reading what it is, but you're gonna turn it into the number. So I see 35 hundredths. So if I were you, I would learn to just write the number that you see. Now we just have to decide where's our decimal gonna go. So they said hundredths with that TH, so you know the number is going to be to the right of the decimal. So if the first number is in the tenths, the second one is the hundredths. So the decimal should go here. Does that make sense? Okay. The second one says 3 and 2/10. Here's what you've learned. Easy. 3 and. As soon as you hear that and, guys, you write your decimal. 2/10. Okay, the 2 is sitting in the tenths place. And then 6 hundredths. So just go ahead and write your 6, and we just need to figure out where the decimal is going to go so that the 6 can be in the hundredths place. So if place value starts tenths, hundredths, I only need 2 numbers for the 6 to be in the hundredths place. Okay, let's move on now. Okay. Find the perimeter of each figure below. The markings on part B here mean that the lines are parallel, and the markings on part E, let me look down here, okay, show that all sides are the same length. As you find each perimeter, be sure to show your work. Okay. I am going to look at A. It's a rectangle, so that should be, actually perimeter should be super easy at this point for you because it's just the outside measurements. So you literally just add up all the sides. So here's what we know about a rectangle. These two sides are equal. So if the top is 8, the bottom is 8. If the right side is 3, the left side is 3. And then you just add them up. 8 and 8 are 16. 3 and 3 are 6. Add those together. That should be 22. So A is 22 centimeters. Never forget to label. Okay, B. We've got a trapezoid here, and all sides, oh no, these two sides are the same. So 3 and 3 are 6, 9 and 5 are 14. Oh, that's super easy. 20 centimeters. Now we've got a triangle. So we've got 13 and 12, that's 25, plus another 5 is 30, and it's inches this time. Let's see. D, 6 and 4 is 10. 10 plus 3 is 13 millimeters. Okay, so E, remember they made a point to tell you that those markings mean all 4 sides are the exact same length, and you really needed to know that because only one side was labeled. Well, if the bottom is 4, you automatically know all 4 sides are 4 feet. So 4 times 4 would be 16 feet. Okay, F, 2 sides are the same, so 10 and 10 are 20, plus the 5 is 25 meters. Okay. Okay, now we're on number 22. So basically we just have to match these vocabulary words with one of these shapes. I noticed that there are more vocab words than there are shapes, so either some of the words won't be used or maybe more than one vocab word can describe the same shape. So let's just keep that in mind. Okay, so on number A, that's obviously a rectangle. I don't even think I need to go over that with anybody. You've known that since kindergarten probably. And I see that rectangle is definitely in there. So I'm just gonna label that rectangle really quickly. B, that if you don't know what that is, I will let you know. It's trapezoid. So the very definition of a trapezoid is, well, we know there will be 4 sides, but only one pair of the 4 sides will be parallel. So as you can see, these 2 are parallel. These 2 are not. So that is a trapezoid. C, it's definitely a triangle. But if you look in the vocab words, I see 1, 2, 3, 4 different kinds of triangles. So we have to make sure we get the right kind. If you will notice this little thing right here, that automatically tells you that that's a 90-degree triangle. So we all know that that is a right triangle. And it just makes that perfect L. That's a right triangle. Gonna do this so that we have less to look at. Okay, now we're at another triangle. Here's what I notice about this one. One side's 3, one side's 4, the other side is 6 millimeters. Okay, not any of those sides are equal. So that kind of triangle is called a scalene, when all 3 sides are different lengths. Okay. Yes. Okay, E. There are 4 sides. They told us that markings on there from the previous question means that they're all the same length. So it kind of reminds me of a square where all 4 sides are the same length, but yet they're tilted. And so we know it's not a square because a square has to have 4 perfect right angles, which would give them the L's. Well, this is kind of tilted, so it's not a square. It's actually a rhombus. That's the difference between a square and a rhombus. Is actually every square is a rhombus, but not every rhombus is a square because some rhombuses don't have 90-degree angles. Okay, the last one is definitely a triangle as well, but what I noticed about this one that's different is that 2 sides are the same. Do you see how the 2 sides are 10 meters and 10 meters? So that makes that an isosceles triangle. Okay, so we didn't use square. There's no hexagon. You know what? Actually, this obtuse triangle, that could also be used to describe this one, and here is why. An obtuse triangle means that one of the angles has to be greater than 90 degrees. That's what obtuse means, it's greater than 90 degrees. This angle right here is definitely greater than 90 degrees, so that makes it an obtuse triangle. Here we go. Okay, we've got another graph. It says use the bar graph at the right to answer the following questions. Before we even look at the questions, remember I told you last time, look at your graph and see what each side is representing. The x-axis looks like it's days of the week, so you can clearly see that's Monday, Tuesday, Wednesday, and so on. The vertical, or the y-axis, is representing the number of people, and look in parentheses, it says in thousands. So I'm looking at the way that they have numbered this, and I can tell there's a 5 and a 10, so that automatically tells me that this little tick must be 1, 2, 3, 4, 5, and so on. But I know that that doesn't really mean just one. I know it means 1,000. So keep that in mind. Okay, so how many people attended the fair on Tuesday? So you go down here and look, there's Monday and here's Tuesday. Go all the way up and then slide over to your left. What number right here is that representing? How about 1, 2, 3? So we know that there were 3,000 people attending the fair on Tuesday. Okay, B, which day had the largest attendance? Okay, so you can just see if the bar graphs go higher, the more people that came, well, you can automatically go to the highest bar. And they're not even asking us how many, they just want to know which day was the most people. So this time you're going to go down and it says Sunday. And then see, what was the total attendance for the week? Okay, what you need to do is look at every day and see how many people and then just add them up, because they want to know how many came for the full week. So on Monday, it looks like it's on the 2, and I'm just going to write 2, but I know it's really 2,000, and when I give my final answer, I'll add my 3 zeros, but I just want this to be quick while we're doing the adding. On Tuesday, it's 3,000, Wednesday, 5,000, and then it looks like 6,000, 7,000, and then Saturday, that looks like 9, and then of course 10,000. Here we go. So when I add up a bunch of numbers, I try really hard to do what they call friendly numbers. I like finding groups of 10 because it's really easy to do that in my head. So immediately I think, well, 2 and 3 is 5, and then that 5 and this 5, there's one of my groups of 10. Here's a 10. These aren't really friendly numbers, but at least I shortened some of it by using it that way. But what I can do is 9 and 6 are 16. And in my head, 16 plus 6 is 22. And now I'm going to bring that 22, and I know that's 10 and 10 is 20. And then 20 and 22 is 42. Now, everybody has their own way of counting numbers quickly, or maybe some of you just go straight down the line. That's fine. I always like to try to show you mental math shortcuts and tricks when I can, because probably a lot of you at this point aren't used to trying to do mental math tricks. But if you just listen and just try them sometimes, before you know it, it becomes an automatic habit, and then math is just quicker. Okay, so that wraps up all the problems for section 1.1.3. Good job, everybody, and I will see you next time.